Hello guys, my name is Abhijitem and today we're going to look at Introduction to Logic Gates, that is CSA section 2. So this is the second session in the series. So this is just for preparation for our internal exams in BCA, Cyber Forensics with IBM, and for robotics. We both have the same syllabus, so let's get started. So the objectives of this session is to familiarize with logic gates and to understand the truth table and Boolean expression of logic gates. So logic gates, the OR gate. So in digital circuits there are mainly three gates. That is the most important gates are AND gate, OR gate, and the NOT gate. So this is the OR gate. The OR gate is like if any of the statements, any of the input statements is true, the output is true. Like if you provide A as 1 and B as 0, the output will be 1, and if you invert it, that is if you provide A as 0 and B as 1, or A as 1 as B as 0, the output is 1. It doesn't care which order it gets, the output is 1 if any of the input is true, and if both inputs are false, the output is 0. It's just like if you know electronics, I'll draw a circuit for you. That is, if you take two diodes and connect them together, this is A, this is B, and this is output Y. So if you don't know what a diode is, I'll explain. A diode is something that allows current to flow in only one direction. That is like it can only flow in this direction, it won't flow in this direction. So that's a diode. So this is like the circuit diagram for the OR gate. That is like if you provide a voltage here, the voltage will come here. If you provide a voltage here, it will come here. If you provide in both sides also, it will come here. But if you don't provide anything on both sides, nothing will come here. That is the logic. It is not complicated, it is very simple. This is the logic diagram or the circuit diagram for the OR gate. It doesn't need any transistors or any other components. It does just need two diodes to work. That is, if you provide plus 5 volts here, you will get plus 5 volts here, and if you provide plus 5 volts here, you will also get plus 5 volts here. If you don't provide anything, 0 0, the output will be 0. That's it. There is nothing complicated about OR gate. And the truth table for OR gate is, I'll show you that, like, this is just what I explained. Is our input both are 0, the output is 0. One of the inputs is 1, the output is 1. Both inputs are 1, the output is 1. Simple. And this is an IC chip, and this is like a TTL74LS family. That's an IC. It's a family of IC chips. Like it's a family of logic, like a family of IC chips that include logic gates, and it's a quad 2-input OR gate logic package. Like it's quad means there are 4 logic gates, and I'll explain the IC chips for you. And in an IC chip there will be like, I'll draw something here. I'll also explain what an IC chip, and I'll draw something here. So this is an IC chip. So in an IC chip there will be like a notch somewhere, and something like this, and there will be pins 1 2 3 4, 1 2 3 4. So this is an 8-pin IC. So if the notch is here, you place that on the left hand side and you start numbering from here, 1 2 3 4 and 5 6 7 8. So this is how you identify the pins of an IC. If you are told to connect to the 8th pin, you place the notch on the left hand side and you connect the 8th pin, that's the last pin, to something like, let's say, an LED. This is not important, I am just explaining what an IC is. So that's what we see here: first pin, second pin, third pin, fourth pin, fifth pin, sixth pin, seventh pin, 8th pin, 9th pin, 10th pin, 11th pin, 12th pin, 13th pin, and 14th pin. So this is a quad input IC, I'm just explaining it because we have to do it in practicals, so that's why I'm explaining it. For internals, this is not important. You just have to know what an OR gate is. Now let's go for the AND gate. So in an AND gate, it is like if both inputs are true, then only the output is true. So how will I'm not sure how to do a schematic for it, but you get the idea. The idea is like if both inputs, if both inputs are 1, then only the output will be 1. Every other state the output will be 0. That's an AND gate. There is no other expression, and this is still a TTL74LS family, and it's a 74LS08 quad 2 input AND gate IC package. So this also has 4 logic gates, and the numbering is same 1 2 3 4 5 6 7 8 8 9 10 11 12 14. So if you notice, you'll see that this is the ground pin. The ground pin is the like 0 volt. Ground is 0 volt. VCC is like in a digital circuit, VCC is plus 5 volts. So that's where you supply current to the IC package, because an IC package requires power to work. So this is where you provide 5 volts, and this is where you provide 0 volt. And this are the inputs and outputs of the logic gates. So if you notice that here also the 7th pin is ground and the 14th pin is VCC. And here also the 7th pin is ground and the 14th pin is VCC. That is because this is the same, like this both ICs are from the same family. So that's it for an AND gate and OR gate. And for a NOT gate, it just inverts whatever input it gets. So if you provide 1 volt, I mean 1 to the input, the output will be 0, and if you provide 0, the output will be 1, and like that. So like it just inverts whatever square wave it gets. If you provide like it's 0, it's 1, it's 1, it's 0, like that. Nothing complicated. NOT means not, like not, I am not accepting the input you give, I'll just invert it. That's what the NOT gates behavior is. Like I just won't listen to you. You can remember it like that. AND gate is like if you give someone something like, let's say you give someone 5 rupees and they're like, and you give them 5 rupees and they give you something back. Like that's an AND gate. OR gate is like, give me anything, I'll give you something. That's an OR gate. And the summary of Boolean expression. So Boolean expression is like, what should I say? The operations, the OR and NOT, these are Boolean expressions. So an OR expression is indicated by a plus sign, and is indicated by a dot, and a NOT is indicated by a like either a bar or an apostrophe. So that's the summary of Boolean expressions. I'll explain Boolean expressions in detail because we have a lot to study in Boolean expressions. So the references, the same references as before. So that's it for the second session in CSA. So thank you guys. See you in the next session. Thank you for watching. I hope you have learned something. If you have any doubts, feel free to text me, feel free to comment, feel free to correct me. If you have made any mistakes, I will correct them immediately. I don't want you to learn anything that you don't want. Like if you want to study, you can study. If you don't want, don't study. Like that's it. Find a passion for computers. It's very any logical person will love computers. That's my policy. So that's it guys. See you in the next video. Bye.